Good morning, friends. I am here again for my course, Aircraft Systems. I feel immense pleasure to deliver my lecture and I enjoy my lecture. Today is my first lecture on aircraft system and I am going to take some case study. Next 15 classes will be from aircraft systems where I will take some special points or a special topic and how these things are developed and how these things are used, because till now I have completed my 40 lectures and this is my 41 lecture, and you might have seen that I have gone as per the syllabus, module 1, module 2, module 3, module 4 and module 5. I have completed all these 5 modules of 40 lectures, mostly nearly 7 to 8 or 9 lectures per module, and hope you people have got some idea about aircraft systems. As you know that I have started with aircraft systems, that is introduction to different aircraft systems, in which I can divide this aircraft systems into 4 main pillars. The first pillar is airframe system or aircraft structural system. That is the first pillar. Second pillar is vehicle system, aircraft vehicle system. In vehicle system, if you see, there are a lot of systems starting with electrical system, power generation system, power distribution system, power safety system, batteries, generator, AC, DC, different types of current generating equipments, their safety measures and all. Further, if I go, I have discussed about hydraulic system. You see that so many components of the aircrafts are operated by hydraulic system. Let it be landing gears, all flight control systems, elevator, aileron and the rudder, also slats, spoilers, air brakes, flaps. These all things are operated by help of the hydraulic system. Also, I have discussed the pneumatic system, few controls which are very essential, and if the hydraulic system is failed, that time we use the pneumatic system, and these pneumatic systems are used to operate all the emergency systems like landing gears, your doors and so many other things, your generators, your lowering of the systems and so on. Air conditioning systems, also to maintain the environment inside the cabin we use the pneumatic systems. Okay, sir. And then I have gone for the next about the engine and its control, fuel systems. In fuel systems, we have seen the gravity fuel systems, pressure fuel systems. We have also seen the different pumps, filters, non-return valve, shut-off valve, and all the things we have seen. And in the last module, I have discussed about the flight control systems, their fly-by-wire system, autopilot systems, actuators. These all things I have already covered. Now in this lecture, I am taking some case studies, how the development of aircraft has taken place. And you can see that the first aircraft by Wright brothers, and they have used a very simple wire system, that is pulley and wire system. And they have tied the elevators, aileron and the rudder by the wire and they were pulling like that. Okay, it was very, very simple. But that time it was invention and it was very much necessary to do such type of things. Aircraft speed was very less and slowly the aircraft speed has become very high. In that much high speed, the load on the flight control systems are very high that pilot cannot handle by its own power. There we need some assistance. That is why the hydraulic systems, pneumatic systems, and all autopilots are being developed, so that the load on the pilot hand is limited and the pilot can handle these things very smoothly. So in this I am going to discuss about system concept and the subsystems, and they are the mapping of the COs or CO1, all these topics. Then I will talk about generic systems, their definitions, aircraft systems, then specification of requirement. These all are coming, they are related to the module 1, and so it is matching with course outcome of 1. So detailed topics I am going to cover: system concept and the subsystem. In this we will see the generic system definitions, input, output, feedback, and the external influence. Then we will go for aircraft systems. In aircraft systems we have the airframe systems, vehicle systems, avionics systems, and the mission systems. We talk about the specification of requirement. We have the mission requirement and the performance requirement. So these things I am going to discuss in few slides now onwards. So first I will discuss about introduction of aircraft systems. So what is an aircraft? So that is the first question of why we ask about the aircraft. And what is the aircraft? So a vehicle that is flies through the lift from air. So the vehicle which fly by the help of air motion and it is lifting upward. So that is called the aircraft. Origin of the word from the Greek. Aircraft systems and the subsystems. Aircraft can be divided into the 4 systems, main systems. First one is the airframe system, then vehicle system, then avionics system, and the mission system. They are airborne aircraft systems, and they are very much required for the flight safety, for the safe operation of the aircraft. The flight safety is very important parameter. The flight safety is very important parameter, and we have to make sure that flight safety is maintained. So these all airframe, vehicle, avionic, and mission, this all system has to play a very important role. So the airborne systems can be divided into airframe or a structural system, then vehicle system, then avionics system, and the mission system. And now I will talk about these different aircraft systems in aircraft. Here I am showing the figure of the reference 1. Reference 1, I have taken this figure from that. So this is one of the very important figure in which so many systems are given in a one slide. Most of all the systems are accumulated here. So here just one see, this arrow shows the ram air. This pink color arrow shows the bleed air. Green arrow shows the fuel. In this blue. Green shows the hydraulic system. Red shows the electrical power. Gray shows the engine oil. And amber shows the fan or cabin air. So these are the 1, 2, 3, 4, 5, 6, 7. 7 type of systems are shown here. And really you will enjoy it, that how these systems are working. I am now going to take a very cautious approach, or I am going to explain one by one. So I will start first with the ram air. So if we see this diagram, we can see that where is the ram air. So this you can see here. This is the ram air. Here is also ram air. So ram is here, ram is here, and so the purpose of what is the purpose of the ram air? So that we have to understand that here just you see 7 and 8 air, it is used for the cooling purpose. Here also air and oil both are the cooled. Here also if you see air and oil is cooled. So this ram air means atmospheric, little compressed. As it is entering here, velocity is reduced. This velocity is converted to the pressure, and this pressure is slightly higher than the atmospheric, so it will propagate in one direction. So these things are used here. Next one is the bleed air. Bleed air is used for, it is some air is trapped from the engine. This you can see here, from here. This is the bleed air. This bleed air is trapped from the compressor stage, some part from the LP compressor and some is taken from the HP compressor. And this goes to the air-to-air cooling. Here this thing is cooled. Then it will go here as a fan and cabin air. Here is the air conditioning. This your turbine will rotate, and a cool air, due to expansion of this hot air, it will enter here, and due to high pressure it will rotate. Due to this rotation, the expansion of the gases is taking place. Due to this expansion of this thing, the air which is there, it is cooled. This cool air is going to the mixing plenum, and where it goes to the avionics compartment or the passenger or the cabin compartment. And if from here the hot air will also bypass, the mixing will take place here, and as per the required temperature, it will supply to the cabin or the passengers where these things are accommodated. Next, I am taking the high fuel system. This you can see most of the fuel is contained in the wings, different panels are here. So this you can see here that this from the wing fuel goes to the engine, but you can see here this is the engine oil. This line is engine oil. This hot engine oil will go here. It will go to this air cooler. From here the ram air will go, and this ram air will cool this thing. Then it will go to the fuel oil. Here it will be cooling, and it will go again. Cooled oil will go again for the lubrication of the engine bearings, and in this way this system is working. But if you see here, this engine oil is also cooled by the fuel. This pressurized fuel is coming, some part is entering here, and it is taking some heat of this oil, and it is again going to the fuel tank. So this fuel tank is little hotter. This hot is again, fuel is taken to again ram air system. This ram air system is again cooling this thing, and it is supplying. So again it is cooled. So for the engine oil, because it is very hot, only air will not be able effectively. So we are first cooling by air, and remaining hot we are cooling by the fuel, because fuel temperature is much lesser than the ambient temperature. So it will cool very effectively. So in this way, next I am talking about the hydraulic system. This hydraulic system, here is a pump. This pump is fitted on top of the engine and rotated by the some gearing mechanism. By the reduction gear, this pump is rotated. From here, the high pressure hydraulic fluid is entering to the hydraulic system, and this hot hydraulic is cooled by the ram air as well as by the fuel system also. And then it is entering again and it is circulating like this. Now I will talk about the electrical system. So in this electrical system, if you see, the electrical generator is also fixed like a hydraulic pump on top of the engine. This is also rotated by the reduction gear. From here a generator is operating, and this operating will go to the generate the electrical power, and this power will go to the different requirement of the system. Now this is the engine oil. Just now I have already explained. These engine oils are used to lubricate the engine bearings. Engine's bearings are in very hot zone, and the oil is heated tremendously. This heat has to be removed, otherwise the effectiveness of the cooling will be reduced, and also there is chances of fire if the temperature of the oil is increased more than the flash point. So this is cooled by the ram air as well as by the air or by the fuel. Now next is the fan and the cabin air. If you see here, from here the fan casing, it is coming. From here the bleed air is taken. This air and this air is again cooled in ram air. From here a cooled air with high pressure air is entering in the air conditioning unit. Air conditioning unit is operated by the turbine, and this is cooled. This cool air is entering to the mixing plenum, and from here another line is going a hot air, and this cool air and hot air is mixed, and from here, as per the setting of the cabin and the avionics system, this is operated here. Here also it is cooled. This air which is coming here, it is cooled here again by the ram air, and in this way it is a primary and this is the secondary cooler, and in this way our system is further cooled. So I have explained 7 to 8 systems in one slide. So if this slide you understand, 50% of the system of your aircraft you can understand, and it is very much required to understand each and every part of this slide. Now I will talk about the systems and the subsystem. We can divide every system into subsystem. So if you see here, here is a major subsystems and its subsystem here. The total system is a system of subsystem. So here is a total system, and here this 1, 2, 3 is a subsystem, again subsystem to subsystems. So like this, if you see here, it is going here subsystems, then it goes to component, subsystems, like this, a lower level of subsystems and its subsystem. So the high level, a major subsystem and its subsystem. So this we can divide, and this I have taken from the reference 2. This you can see here. So this system and subsystem concept we have to understand very well. Subsystems and subsystems, it is continued again. So here this you can see that individual systems here, airframe systems, avionics systems, mission system. A part is individual system. Then B is integrated functions. They are integrated to each other. 1, 2, 3 here, 1, 2, 3, 1, 2, 3. So this airframe systems, then avionics systems and the mission systems all are integrated. Then we have the C, cross function characteristics. Sometimes one system is attached to the another is attached to the another. So these all are attached and they are incorporated into aircraft design. So in this way we have to design the system in such a way that all the systems are integrated functions. They are also cross function to each other and also incorporated, this all parameters to be incorporated in the design of the aircraft. Now I will talk about the generic form of a system. In generic form of a system, Factors influencing a system. So what are the factors which affect the system of the aircraft? First one is the safety. Second one is the integrity. Third one is the availability. Fourth one is the mission success. Fifth one is the customer perception. So any system once we design, every system should be safe. It should not hamper anyone. It should not burst. It should not create some gases which is affecting to the human. It should be also environmental friendly. So safety first we have to see that the user customer which is using this thing, he should not get any type of problem by this. Then integrity. Every component of this thing should be integrated to each other and they should function properly. Their interdependency should be increased. If one thing is failed, whole system should not be failed. So that type of integrity is required. Availability, the system which is designed, it should be in low cost. It should be available everywhere as and when required. Any parts, when it is damaged, the spare parts should be available at the very minimum time and less amount of money. These are things we have to take care of. Mission success. Mission of the design, any system, it can be only success when all the components are working together and all the systems are doing their best performance. They are very safe, they are integrated and they are also available. Then only mission can be success. Customer perception, you should make very nice look also. Customers should feel very happy to hold your design of the system. It should function. It should also have a smooth function. It should not generate any noise. It should not generate any other issues. Then only customer will be satisfied. This all if you make good, then it will introduce a redundancy. The failure capacity of your system will be reduced. In aircraft, we use very high level of redundancy so that it can be used for a long time. To compensate between failure and a certain degree of safe operation, we use dual redundant system. So minimum in aircraft, we should have the dual resistant. Dual redundant. The system should be dual redundant. That we have to make sure that our system should work. If one system is failed, another should take over and your system should operate continuously. So redundancy of the aircraft should be maintained at all cost. Generic form of a system, this we can see here that we can divide into three groups. One is the input, another is the output, and another is the functions and process of the system. So what input we have to give? We have to give input of demand. We should have some sensors. We should have some other systems. We have some feedback. These are the energy. This from here energy is given to here. Here it will be functioning. Then it is processing is done. Control is achieved. Local feedback is provided. From here it will go to the output. The output may be the waste product. It may be the flight deck. It may be the other systems. It may be the effector. Energy will go and power source will be there. From here, if you see, this is the feedback. This feedback has to go here. Then it will go here. Feedback is very, and it will be correcting here. This is your correcting errors. Whatever you are getting here some errors, this error has to be rectified by your system. So feedback is one of the very important parameter by which only you can take the system forward. Further, I am talking about another generic form of a system I have taken from the reference 2. So here the aviation system environment, this is especially for the aircraft. So in this aircraft what happened? We give some input. Input, what are the inputs? we can give the materials, components, people and energy. Materials means different types of materials. We can give different type of hydraulic systems, pneumatic systems, different components, hydraulic pump, pneumatic pump, NRVs, then valves, shut-off valves, people also, and different types of energy we give, and this will go to the process function. Here, this all inputs are processed as per the desired requirement. From here, it will go to the output. Output, what are you going to get? You are going to get energy transfer, data, or waste product you will get. And if any errors are there, this error will be transmitted to the feedback. This feedback will go to the again input. Input will be modified as per the output, and accordingly the process will continue. So it is a circular process by which the systems are operating. Now, classification of the aircraft systems, we can divide in aircraft in different classification. This you can see the aircraft here. We have the airframe and structural system. We have the wing, empennage, and the fuselage. So just I will talk here. So this is your airframe. So here first one is the wing. Here is the wing. These wings are used to give the lift of the aircraft. Empennage, if you this much part from here to here is empennage. Empennage consists of the horizontal tail with elevator, vertical fin with rudder, and last 20% of the your tail. This is called the empennage. Third one is the fuselage. Fuselage is full. The body of this aircraft is called the fuselage. In fuselage, your wings are fixed. Your engine is also fixed. All the passengers, electronic equipments, avionics equipments, fuel, all the things are stored in the fuselage. If you talk about the vehicle systems, we have the fuel systems, we have the propulsion systems, the flight control system, and the hydraulic system. In fuel system, we can see that we have the fuel is stored mostly in the fuel wings and some part on the fuselage. These are having some fuel pumps, then filters, then distributors, shut-off valve, selector valve, non-return valve, filters, and so many items are there in the fuel system. If you talk about the propulsion, the propulsion is nothing but to give the thrust for the engine. Thrust is produced by different types of engine. Engines we can divide in two groups. One is the reciprocating engine, and another is the rotary engine. In the reciprocating engine, we have the 2-stroke engine, 4-stroke engine, CI engine, SI engine. If you talk about the rotary, we have the gas turbine engine. In gas turbine engine, if you talk about the turboshaft engine, turboprop engine, turbojet engine, turbofan engine, these are the rotary or the turbo engines. Most of the time we use nowadays the turbofan engine. Turbofan engines are very efficient, and it is nowadays used for all type of aircraft. If you talk about the flight control systems, the flight control primary, we can divide into primary flight control and the secondary flight control. In flight control, in primary we have the elevator, rudder, and the ailerons. In the secondary, we have the flaps, slats, slots, air brakes, spoilers, and so on. And in hydraulic systems, also we operate so many equipments by the help of the hydraulics. And like your landing gears, doors, your flight controls, engine controls, and all operated by the hydraulics. If you talk about avionic systems, we have the navigational control, display, and the communication. Navigation control means in which direction your aircraft goes. If any errors is happening, navigation will try to solve and it will correct the headings. Display, in our cockpit we have the different displays, so it should be displayed properly. The communication between pilot to ATC the pilot or some other agencies, the communication should be maintained very thoroughly. Once we talk about the mission systems, in the mission systems we have the sensors, mission computing, weapon systems, and so on. These are the references from where I have taken these things. That is the Moir I and the Seabreeze, aircraft systems, mechanical, electrical, and avionic systems, professional engineering, Publishing Limited, London, and Paris Saint Edmund. Another book also from the same author, Moyer and the Seabridge, Design and Development of Aircraft Systems and Introduction, AIA Education Series. So, any questions you are welcome to ask. My email is ydwivedi@gmail.com. So you are welcome to ask. Also, I request you to subscribe and like this video so that I will get the encouragement. Thank you very much for the joining, and hope this might have given you some insight into the aircraft development, aircraft system development, which is very much essential for any type of systems of aircraft. The system engineering is very important, and every aeronautical or mechanical or any students or any people who want to learn, this is very important course. Try to understand these things. So in this way, I am ending my lecture here, and hope this will give you some inputs.
Like, share and subscribe. Hit the bell icon for more updates.